Hi, this is Julia Lane again, and what I'm going to be talking about is machine learning and clustering techniques. And as before, I owe a great deal of debt to my colleagues. So there are two different types of models, broadly defined. You heard Brian Kim talk about supervised learning in the other set of videos. What this video is about is talking about unsupervised learning, which is often also called clustering. So what I'm going to do today is talk about what it is, how it can be used, particularly in the public policy context, and how does it work. So the classification or prediction models that's supervised, where there is an outcome measure that you're looking at. So we're used to think about that in regression analysis. Clustering is analogous in the social science world to principal components analysis, in which you don't have an outcome variable. You actually don't know which groups people fit into. What you're trying to do is you're trying to figure out, based on a set of characteristics, how much different data points are like each other. So the notion of similarity is critical in clustering. It's used for a whole variety of things. If we're trying to do market segmentation and trying to figure out, you know, are you going to be a beer purchaser or a wine purchaser, and what kinds of wines you're going to buy, that's identifying similar markets. For similar firms, as we'll see later, we'll think about firms that have high wages and upward employment trajectories for their workers versus ones that don't. You can also use clustering to say similar documents. In other words, when you're looking at scientific documents, you can say this was written in the economics field versus it was written in astrophysics. So those are the kinds of applications that they're used for. So as I said, clustering is when there's no prior knowledge about the groupings of the entities that you're looking at. And what you're trying to do is you're trying to explore it, you're trying to understand historical patterns, find groups in the data, and you can think of lots of different examples. So here's one example. Look at this list of cities. Now, if I wanted to figure out and group them by something like geography, I might group the top cities as American cities and the other cities as the rest of the world. I could also think about these cities as being grouped by whether whether they are large major cities in each country, or whether they're smaller, more regional hubs. So exactly how they're grouped is obviously going to depend on what data you feed into them and what kind of questions you're asking. So that kind of leads me up to, what does clustering do? What it essentially does is it groups similar entities together based on the features. So the features, as you remember in computer science, that means a variable. Similarity can be variously defined. The most common measure is a Euclidean distance, that is a distance based on numbers. Obviously, when you're dealing with different questions, you might use different types of distance measures, and there's a whole lot of literature on the types of measures that can be used. At the end of the day, though, your approach is essentially, I want to bucket like into like, and I want to bucket things that are different into different clusters. So that's what intra-cluster similarity means. That is, I want people who are or firms or entities that are very similar to show up in the same cluster. And I want things that are different to show up in a different cluster. That's what intra and cluster similarity means. So here's an example. If you're interested, for example, in welfare, and a major survey is survey of income and program participation. In some work that we've been doing at the Coleridge Initiative, we've been trying to figure out what are data sets that are like the data sets of the survey of income and program participation. So how can we figure out like Amazon.com, you know, if you liked this book, here are other books you might like. So you use that based on how much these data sets co-occur in publications, and that little network picture groups the articles and groups the topics and the data sets according to some measures of similarity. So there's lots of applications for clustering mechanisms. And if you want to, you can go onto that website, rc.collegeinitiative.org, and poke around at different data sets. It's a pretty cool project. Let me give a more concrete example, which is labor market. So you will recall that in the intro video, I talked about the difference. One of the values of machine learning is that it got the data to establish the rules, if you like. And we're going to talk about how that works in labor markets. A couple of, maybe a dozen years ago, Harry Holzer, Frederick Anderson, and I wrote a couple of books where what we tried to say was where you get a job matters. The firm characteristics could be as important as your individual characteristics in informing your future earnings trajectory. And what we did was we kind of created some rule-based measures. We said, you know, if it was a high turnover firm or if it was a firm in retail trade, you were much less likely to have a good earnings trajectory than if it was a low turnover, high average pay firm. So the firm characteristics matter. Obviously, for policy purposes, that's an interesting question because, you know, it's pretty difficult to change the demographic characteristics of an individual, but you can work with firms to improve their HR practices. And that was the story of these two. Now, in a class that we taught a couple of years ago, 3 years ago, a group of participants in the class looked at an example of this for New York City welfare recipients. And so what they wanted to do was they wanted to find a job sector. And what they did was they used clustering to classify a job sector. So what they did was they looked at the industry, they looked at the earnings, the job creation rate, the turnover rate, and they used a k-means algorithm for the cluster analysis. I'll talk about that just in a minute. And what they did was they clustered the areas by high earnings, high creation rates, and low turnover rates. Those were the three features that they used. And people who got jobs in the cluster that was identified by a green dot did better. Welfare recipients who got jobs in the clusters with the red dots didn't do so well. And they talked about what the job sectors were in each category. And you can see department stores and individual and family services largely had lower earnings, lower job creation, lower turnover. The best sector to go in turned out was physicians' offices, not surprisingly. They had higher earnings, higher job creation, lower turnover. So anyway, that was a very interesting initial study. It enables you to characterize the labor market into clusters. You know, there are many, many industry sectors and so on. And, you know, then you can look at a narrow set of independent variables, which is the cluster on individual earnings. So that's just an illustrative example of how this works. So I'm going to talk now about clustering methods, and I'm going to largely talk about k-means. There are many other approaches that can be used, and I encourage you to explore the literature on this, but I'm going to walk through the k-means because it's pretty popular, it's pretty fast, it's pretty effective, and you'll also have a notebook associated with it. So here's the basic idea. Now, how does it work? So it's very sensible in the way in which we think about doing things. What you do is you have a whole bunch of data points, and what you want to do is you want to figure out how they're going to group together. So essentially, we're going to choose K. So the reason it's called k-means is we're going to presuppose how many clusters there are. We might say 5, we might say 10, we might say 20, whatever it is. We're going to start there, and then we're going to look to see how they all match in, see what the distance measures are, then we move everything around, and then keep going back and iterating until you've met a convergent criterion. So you'll see here, remember we said define machine learning. You're going to give it a task, you're going to give it some data, you're going to have a performance metric. This is precisely what the clustering mechanism is doing. So here it is visually, and thanks again to Ray Ghani for putting this together. So what we're going to do is we're going to just randomly pick, we're going to say 3 means. We're going to pick some cluster centers, K1, K2, K3. I know I'm very imaginative in the numbering here. And then what we're going to do is we're going to put each of these points in the nearest cluster. So I'm just labeling this for the visuals, labeling K3 white, K2 red, K1 green. And then I'm just going to say whatever is closer, I'm going to look at each dot and say, how far are you from K1? This guy is closest to this one, so we're going to color him green. This one is closest to this one, so we're going to color her green. This one is closer to K2 than to K1, so we're going to color her red, and so on. So now I'm going to calculate the distance metric and then move each cluster center to the mean. So I'm going to move this guy over this guy to the center, and then going to move this this centroid to the center of the green dots and the centroid. And then I'm going to say, well, wait a minute, now that I moved this to the center, if you take a look back, if I move this guy to the center, I'm going to orphan some of these others. So remember, I moved the red guy down, I moved the green guy into the center of the greens, and if you look at it, that's orphaned this guy. He or she is going to be closer to the red than to the green. So I'm going to reassign him to the red group, okay? So that's the basic concept here. We're just going to keep reassigning data points to their closest neighbor and keep iterating until we get our clusters set up. Of course, now that we've moved those guys into a different group, so I now have to recompute the mean of the red group. I have to recompute the mean of the green group, and I have to recompute the mean of the white group. So then I have to re-estimate the distances, and that's how I end up with my clusters. So that's the basic concept. If you want more information, it's available obviously in our terrific textbook. But since we're also social scientists and interested in public policy issues, there's a very good summary in the AP and Gimlin's piece. Thank you very much for your attention.